Good morning once again. Thank you for joining this session. As you all know, previously we had first session on structural simulation on pump assembly. In today's session, we will be going through the buckling analysis, how buckling analysis can be evaluated with respect to SolidWorks simulation and Abaqus. I see people are yet joining. Okay, myself Shamil. I work here as a application engineer for simulation at Solid Dimension. So I have overall 5 years of experience with working with structural and CFD simulation. Okay. What's today? We will see what's the progress on this training series. We will have what we have completed so far and what are our future plans on this training series, and we will see what basically is buckling simulation, or what is basically buckling and buckling factor of safety and calculation, how you have to evaluate if you have a buckling phenomena coming into the picture. And we will see a simplified stool assembly, how you can set up a, or basically the workflow, how to set up a buckling simulation, how to do the result interpretation with respect to SolidWorks simulation, as well as with respect to 3D experience Abaqus. And we will also having the value offering, as well as we will have at the end of the session, we will be having a Q&A session, right? As this training progress, whatever the concerns or whatever the questions you have related to this, or whatever related to the simulation, please feel free to put up in the Q&A session, which is available in your Microsoft Teams. Let's learn simulation training series. As I already mentioned in previous session, why we have come up with this training series is because today all the industries are looking for the design engineers who knows to at least perform the virtual validation with respect to the whatever tool it might be, right? Whatever the design you are going to do, whether the model or the product is going to work in real world, so these kind of validation report needs to be created during the design phase itself, or at the initial phase itself. So whatever the design you do, so you will be defining whatever the boundary condition or real world condition, and you are going to submit a report like, so yes, this is what the modification I have done, and this is why. It is kind of a justification for your modeling part, right? As I told, the training series, what we are mainly focused on this year is basically to understand the fundamentals on FEA and CFD, the basic level of knowledge and introduction to the tool. And I'll be also, as this training series progress, I'll be also taking through one simple example, like how that can be defined with respect to the tools. And in the once the fundamental training series is completed, we will be mainly focused on intermediate to advanced level simulation with respect to industry specific problem, right? So what's the training series progress? This is our second session. So first session we've had a static analysis, a very basic assembly level analysis. So how to define the interaction, how to define the connections or connectors with respect to the assembly analysis, and how to evaluate your results, right? These recordings are been already published. I see couple of people were asking regarding the recording issue. Yes, now we have published this recordings in our YouTube channel as well, right? Whatever, if you have any concerns related to accessing the recordings, please let us know. We will help you out in that. What is buckling, right? So buckling is a mode of failure where sudden large displacement happen due to the compressive loading, right? So when slender like structures are subjected to the compressive load, there is a sudden displacement occur, right? Whenever you have kind of a slender member, so basically your weldment structures kind of thing, or a compared to the cross section to compared to the length, right? So when the ratio is in such a way that, and when you have certain kind of compressive load acting on it, right, there is a chance of having a buckling failure rather than the yield failure, right? So rather than based on the loading condition, rather than having the permanent deformation, there is also chance of having a buckling failure, right? So so basically what you get from the tool or what you understand by performing the buckling analysis. So basically once you perform a buckling simulation, right, so you will be understanding the buckling factor of safety. The tool is going to tell, once you set up the analysis, the tool is going to showcase what is your buckling factor of safety for your model or whatever the design you have done. And based on that, you can come up with the conclusion like whether the model is going to yield first or fail with respect to yield, or even though the model is not going to fail with respect to yield, whether the model is going to buckle, right? So whenever you have a BF factor less than 1, definitely your model is going to have the buckling is expected, which is says in the second row. And if you have, if the buckling factor of safety is more than 1, yes, that means there is no prediction of buckling, right? So if the negative, that means you, if the given load you have reversed it, then you are going to get the buckling phenomena. So this I will be showing in the tool, like how to set up the analysis, how to take this buckling factor of safety, and how you can interpret your results with respect to the static simulation or linear static analysis you have performed, right? So this is basically the calculation for buckling load. So for example, you have applied, so just if I take my paint or something, so just consider like this is my structure or something. Okay, this is fixed and there is a load called F, which is equal to 100 Newton. This is just an example, right? So you performed a buckling simulation for this and you are getting a buckling factor of safety, which is equal to 1.5. That means what is your, so this means this load, under this load, this structure is not going to buckle. This is what it says, first thing. And the second thing is what is the critical buckling load. So basically what is the critical buckling load? So if you into 2 means basically F is equal to 1.5 into 100 Newton, that is basically your 150 Newton will become your critical buckling load for this structure, right? So I'll be showing this in the same in the tool as well, right? So this is how you calculate. So to calculate the buckling load, for example, if you have a force of 500 on the face, right? So and if you are getting the buckling load factor of 2.3, so 500 into 2.3, basically 1150 on the face one will become your buckling, critical buckling load factor of safety, right? So what is basically linear versus non-linear buckling, right? So initially, predominantly before going to the non-linear buckling, when you do a linear static analysis, it is important to evaluate what is the linear buckling factor of safety, right? So linear buckling factor of safety, when you do a simulation for linear buckling factor of safety, you are going to get two factors. One thing is buckling factor of safety, and this simulation will also estimate the critical buckling load, and which will help to understand whether your model is going to yield or buckle first, right? And when you have to go for a non-linear buckling simulation is to accurately understand the post buckling effect. So once the buckling has happened, right? So what will be, this is basically the advanced simulation part, which I'll be covering on the later training series. So just to, for the information, so once the buckling is happened, so how the structure is going to actually buckle, right? So the post buckling effect can be analyzed with respect to non-linear buckling simulation, right? So now we will see how with SolidWorks simulation I can perform this buckling analysis. So let me open up my SolidWorks. So sorry for that. So desktop working model. So I have a stool. So I have a simple stool assembly, which is the legs are on the, considered to be the slender member, right? So let me create first. So if I go to my products, So you can see I have simulation premium, so I can perform buckling simulation. So under the simulation, so as I told before performing the buckling, the first thing is you have to perform a linear static analysis and you have to see what is the factor of safety for the linear buckling analysis, linear simulation as well as a linear static simulation, and then you have to perform a buckling simulation. So how easily we can predict it, we will see that. So just I will go for a new study. I will choose static. Let me name it as stool stress analysis. Okay, this is the name, whatever is convenient for you. So once applied, the feature manager is going to divide. You can see a right check mark here. I have already applied the material. So basically the material has been transferred from your SolidWorks to the simulation, right? So if you want to change the material, you can change it from here. So as I told in the previous session, make sure these values are very accurate with respect to the data sheet you use, right? So once that is done, so material is already applied. So let me go with the fixtures, right click. So basically this tool, these four legs will be fixed at the bottom, right? So you will have 6 degrees of freedom in the X, Y, Z and rotational along 3 axes, right? So I am going to fix all 3 directional load. So if I go right click fix geometry, if I fix this, right? So what is going to happen? The entire degrees of freedom is going to constrain. Here you are not going to get the rotational aspect as well. So to evaluate that, so what I will do, just I will go with the advanced fixtures, not advanced fixtures, a remote load and mass, right? So I will choose which phase I need to fix. Okay. So this is basically this option comes under external load, which can be defined it is as a boundary condition as well. So remote load and mass, I will choose this phase. Okay. And I will go and choose the coordinate system already, whichever I have created with respect to SolidWorks. So this is the coordinate system. Yes, I'm going to choose the coordinate system. So just scroll down. Now translation component you have, just I will activate all these things, right? So this is with respect to force. I am nowhere with respect to force. I am going to fix the, so this is basically your force. This is your translation. This is your SI units and basically the translation SI unit. I am going to activate these 3. Now you can see location, this phase, location 000, which is your basically your coordinate system, and translation along X, Y and Z. So basically the X, Y, Z translation I am trying to restrict. So this will be, so rather than if I'm going to fix this, right? So what is going to happen is your stool, basically these legs are going to be more stiff, right? So to have a kind of more realistic, I have tried to go with the other one. So this is how you can, so one more case I will show. So remote load, just go to the phase, you have to fix global coordinate system. So user defined. So make sure which coordinate is inline here. Coordinate system and location I am going to give exactly, because coordinate system, how with the SolidWorks, this is a CAD feature, right? So once the coordinate system is created, make sure you activate all the 3 and make sure you activate the translation, give the location as displacement as 0, means X, Y, Z, the movement of this face is constrained, right? So this is how you can define it. So let me delete this because I have already defined. So if I go to there, so basically these 4. So this is also one more good feature. If you are running a multiple simulation, just drag and drop the features from the different this one. So you can see all the loads, all the constraints has been applied, right? So next thing is loading condition. So loading condition is basically, if I go to the forces, so the sitting was whatever the force or the whatever the pressure or the force acting on this face. So in the, I will choose any one of the plane and the downward direction. So just reverse the direction. It is in the downward. So whatever the value, so 8900. So 8900 is my Newton applied on this. Okay. So let me click OK. So now if I right click show all, if I go here uncheck, and if I check on simulation, you can see, right? So the constraints are happened and I have also defined the loading condition. So this part is done. So let me hide this. So next go to the meshing, create a mesh. So right click on the mesh, create a mesh. Okay. So I will go with the default blended curvature. So meshing is running on the other window. Yes, meshing is done. So you can see the meshing is done. So once you create the meshing, it is important to evaluate what is the quality of the mesh, because totally your results are going to totally depend upon the mesh, right? So right click, I will just go for create mesh quality plot, aspect ratio. Let me choose as floating. So you can see maximum my aspect ratio is 17. This is fine enough because I do not have much. So if I go to the details, okay, less than 3 is less. Okay, so I need to improvise this mesh. So basically compared to this face, these locations are very slender. So I will just hide this. Let me create a apply mesh control. Let me choose all these faces. So basically, this is basically the local refinement of the mesh. So I'm going to tell the software like, yes, these location I should have very smaller size of mesh. So I'm going to just choose this, zoom in. Yes. If you want to have a complete, you can also choose everything. So now I am focusing on only on these leg structures. I should have at least like 10 mm a mesh element. Just click and just remesh it. Click OK. So meshing is running. So if you're getting any doubts or questions, please put up in the Q&A session. So once the meshing is done, if I see, yes, it has improvised compared to the last. Okay. So let me run this simulation. Yes, it's running my static analysis. Yes, so the simulation is solved. Okay. So this is not the actual deformation. If I go here, this is almost scale up. If I go to the true, I will get the exact whatever the deformation looks like. So this is my, so if I animate, you can see how the stresses are. So what is the conclusion from this result, right? So your yield strength of the material is somewhere around 206, but after performing the real world condition, I understood like, yes, my maximum even after applying 8900 Newton of load, my yield strength is well below my maximum one messier stress is well below my yield strength. Therefore, we can conclude like, yes, this is safe. This model is safe, right? So if I go to the displacement, so same way you can animate. Again, this is not the actual deformation. So if I go here, right click, you can just go to the true value. So let me quickly go to the factor of safety with respect to von Messiers, right? Yield, these are all from the material property. And you can see your factor of safety is 1.3. So this is basically how you perform a linear static analysis. If I go to the simulation, you have report option where you can extract all the reports, right? Now I am going to perform a buckling simulation. So create a new study, choose your buckling analysis. So let me name it as stool buckling analysis, right? So this is the advantage of using a 3D integrated kind of software. So already I have performed it. So just go. I know material for my buckling simulation remains same. Just copy paste. My loading condition, my fixtures are going to remain same. Just copy paste. And even the mesh, it is going to be same. Just copy paste. So if we go back to the buckling simulation, almost it is like 70% of your simulation setup is done. Just what you have to do is right click on the property, make sure you how many buckling modes you have to consider. So basically, usually we will always see the first buckling load factor of safety and we will compare with the yield. So let me go with 2, click OK. That's all. Just run this simulation. So the stool buckling analysis is running. Okay, so this is my buckling simulation results. So if I right click, the results options are here different, right? So if you see, you have list buckling factor of safety. So if I see, you can see my first buckling factor of, this is the first thing we have to see. So my first buckling factor of safety is 3.6 and my second buckling factor of safety is 7.27. So you can see you have this kind of deformation for first buckling, and in the second you have this kind of. So what is the output of this? So basically what the results are going to tell, so you are going to get the buckling stuck. One thing is, one thing to conclude, this tool first, it is not going to buckle because my buckling factor of safety is more than 1. This is first thing. The second thing is, if you multiply 8900 with 3.62, right, your model is going to, that is going to the critical buckling load for the first mode, and that mode is going to be in this form. Okay, so this is what the conclusion. So how to conclude with respect to whatever the static analysis you have performed and buckling analysis you have performed. So let me show it. So how to result interpret? So as I told, with static simulation, I got factor of safety of 1.3 and buckling factor of safety of 3.1. So from the table, what I understood, yes, there is no buckling because buckling factor of safety is more than 1. So buckling not predicted. Again, the question will come like, will the stool is going to buckle or yield first, right? So what we understand, the stress factor of safety is lower than the lowest buckling factor of safety. So we can predict like before buckling, for this example, before buckling, your stool is going to yield first, right? And however, the yielding, definitely once the yielding happens, the geometry and reduces the buckling load, and finally this stool is going to collapse, right? So that's what I was talking on the post buckling phenomena. Once the buckling has happened, once the yielding has happened, how you want to evaluate how the collapse is going to happen or how the buckling is going to happen. In that case, to understand the post buckling effect, you have to perform the non-linear simulation. So this is basically the non-linear buckling analysis which I have performed in SolidWorks. So let me give one more case. So just like example, I believe I have that model. Yes. So in the training series, it will take more time to run. So just I believe I have already run. So static. So here I have all the weld structures, forces, everything. So if you see the factor of safety of this is my basically the static analysis. You can see it is 8.5, right? So this model is well below, means well below the yield limit, and this is very much fine, right? So if you go to the buckling load, you can see the first buckling load factor of safety is 4.1. This means your before the yielding happens to that model, your before the yielding is going to happen with respect to this model, your structure is going to buckle. So this case happens with everything. For example, in the stool case also, if you have the factor of safety of, just a second. Yes, if you have the factor of safety, just a vice versa, your factor of safety for the stress is 1.3, and whenever you have performed a buckling analysis and it says 0.8, even though in the yielding your results are, your result says yes, the model is safe, but in the buckling factor of safety it says less than 1. That means even before yielding the model is going to buckle as well. Right. So this is how you can interpret with the linear buckling phenomena. If you want to see how this collapse and how the post buckling effect happens, you have to perform the nonlinear simulation, which I will be doing in the advanced simulation training series. So quickly I will show in the same example how you can perform the same scenario with respect to the 3D experience. So basically with the Abaqus solver, so right from the SolidWorks, you have option to save the model to the 3D experience platform, right? So once the files are saved, so please let me know if you have any questions, please put up in the Q&A session. I'll be answering at the end of the session. So once the file is saved, I will go to my a role, structural designer, which is used to perform the linear buckling simulation. So once I click on that, so you can just name it, you can give the buckling analysis name. So buckling analysis of stool, I'm just going to define it. So yes, here I have to choose like which analysis I am going to solve with Abaqus. So I have to choose like, yes, the buckling phenomena I'm going to solve in the setup. So it's the same procedure. So go to the local mesh, specify wherever the lesser mesh you want or refined level of mesh you want to define. This is not going to take more time. So once you have selected all this, just define it as 10 mm, right? Generate mesh, click OK. So once the mesh is generated, right? So the next thing is, you can see the assistant panel you have on the right, just you follow that procedure. So you go to the material, just click on the material palette. So your material palette is going to open. So just drag and drop. So I have the fatigue property in this material as well. So it is, I have named it as fatigue. So just click on. So once the material is defined, so you have to just define the boundary condition. So fixed displacement in X, Y, Z direction, which is same. I have defined it there. Just choose all the faces. The result interpretation as well as your pre-processing, the setting up the problem, it remains same, right? So once the load is applied on the top, which is 8900, so straight away you can just solve your simulation. So as you all know, with cloud, you have the HPC coming into picture where you can perform with advanced HPC computing with more cores as well. So once you start the simulation, it is going to take up the license what you have. It will read all the Abaqus. So basically here it is going to create your Abaqus data input file, data file, message file, and the log file. So once the simulation is solved, so extract the simulation. So next you can do the whatever the post processing, what it is same like post processing, whatever we were doing in the SolidWorks simulation, right? So this is what on the buckling analysis. So this is basically the linear, the first stage of once you perform when you have a slender member, first you have to perform a static analysis for your loading. And if the slender member is subjected to kind of compression, you believe there is a chance of happening a buckling, the structure is going to buckle first, then you have to set up a buckling simulation, and then you have to take out the buckling factor of safety. Then you have to correlate your results with respect to yield factor of safety and buckling factor of safety. Then you have to come with a conclusion, right? So this is the value offers we are running this month. So this is same as like we have certain discounts on the SolidWorks simulation portfolio, where we will be having a free training for the customers. So basically, we will be providing 2 to 3 days of training based on the package you have. So additional to this, once you have the and even the customers who already have the simulation license, they will be having a access to SolidWorks simulation professional certificate. If anybody is willing to take that SolidWorks simulation certificate who has this simulation license, please you can feel free to contact me. I can assist you in that certification as well, right? So in the flow simulation offer, yes, we have certain offers going on flow simulation. Again, we will be having a industry specific training with respect to the tool for the flow simulation and multi-physics simulation offers, where if you have the SolidWorks simulation premium and flow simulation, you have a certain discounts coming from our SolidWorks team. And we will be also giving a free online training for 5 days. So basically it will be covering all the structural simulation as well as the flow simulation, right? So you have one poll. Before I addressing your questions, I can see there are certain questions coming. So I just wanted to know what kind of simulation you are willing to participate in the future, or just a second, it's loading. So I'm just launching a poll. Yes. So please answer those polls. So basically, what physics simulation topic would you like to explore in future simulation training? So this I have given as a multiple option kind of. So you can choose whichever the simulation you are predominantly working with respect to your industry or with respect to your organization, or what kind of analysis you usually deals with, or what kind of simulation you usually deals with. So here you have option for large assembly submodeling concept. So basically to do a large assembly analysis, structural thermal simulation, basically you understand the thermal residual stresses and temperature, and basically the frequency analysis, the topology optimization is there, fatigue analysis to assess your life assessment testing, right? And dynamic simulation, non-linear analysis. So these all addresses your basically the structural part. And on the fluid, the CFD, fluid flow analysis, so fluid flow simulation, basically to understand the flow parameter. So if you are dealing with such kind of simulation, let me know. So based on this poll, whoever is more interested, I will try to segregate my training series based on these inputs, right? So it will be more to the audience requirement, right? So thermal simulation, so basically the CFD analysis, thermal simulation, so heat transfer problem. So if you have kind of electronic enclosures or PCB kind of related analysis, or the heat sink designs, so these kind of thermal simulation, if you are willing, let me know. I can put up that in the training series. And HVAC, yes, human comfort parameter simulation with respect to SolidWorks flow simulation. And finally, the plastic injection molding. So if you are into the plastic part designs, right? And if you are trying to see whether the plastic injection, how my plastic injection process goes, and whether it can fill or whether it can have the DOM, the design of manufacturability, so that can be assessed with respect to SolidWorks plastics. And that's all from my end. Thank you. Thank you for joining this meeting. So if you have any, as I told, if you have any concerns, please feel free to contact me. Thank you. Thank you very much.